What will be done within the framework of the project, specifically this crowdfunding project, in 3 to 5 years? During this period of time, you can build an MVP, minimum viable product, a break-even business cell that will be self-sufficient due to the processes we will establish, namely the development, production, and operation of airships. The first thing, naturally, is the team. The team is already 95% formed. The formation of the team is now divided into 2 stages. The first stage is the creation of an engineering center within the project. This is a quick sprint stage, and it is 95% complete. The next stage will follow a little later. It is the formation of a full-fledged design bureau. It will be necessary for the design and construction of vehicles of a larger size than the one that has already begun. Let me go back to the team. Well, here is an engineering center, which in the future will turn into a full-fledged design bureau. The first step is, of course, the team. And now a vehicle is being created in the engineering center. Scientific and Technical Council was held. At that Scientific and Technical Council, we determined that the first vehicle should appear, first of all, very quickly. Secondly, as economically as possible. Well, we can't say that it will be cheap. It's necessary not to build something cheaply. It should be with good quality, but economical. And we came to a conclusion that if at the first conference we stated that a separate airship shed will be built for the first vehicle, but then we faced reality. It is land acquisition, it is putting the land into operation. There is a lot of administrative work and paperwork, then design, construction. Well, while all of that will happen, this airship shed will appear in 3 years maybe, and it's not that interesting to make that vehicle in 3 years as it will be a year, for example. So, to make it in a year, we have to use the existing infrastructure, and that infrastructure is a standard airship shed with a gate height of 12 meters. That's one limitation that fell on the shoulders of the first vehicle. And the second one is its competitive technical advantages. Anyway, we had to choose the speed. We chose around 120 kilometers per hour. And then everything formed by itself. Its volume, appearance, what engines, propellers it would have, where they are, what they do. And it turned out to be a vehicle of 2,000 cubic meters. And this vehicle is being designed now. It is designed in such a way that at the output, after, 3 different modifications, we got a full-fledged, commercially viable, unmanned aerial vehicle that will be able to perform certain functions. And the functions it will be able to perform, well, there are airplanes, Soviet light aviation, which is still used in Yakutia, for example. N2 constantly fly in the region. N2 flies its last motor hours, and that useful work will still need to be done by somebody, and most likely this vehicle will be able to do it. Let me repeat once again that we are planning that it will fly in a year. It will be designed in such a way that we can work out several versions, options on it. It's a combined nacelle and a disconnected nacelle. It's 2 rotary propellers or 1 propeller plus 2 thrusters. It's certain type of tailing and so on. Anyway, the first shell will have it, all the possibilities for modifications, in order, first of all, to experimentally work out the best design for the vehicle itself. And secondly, to work out the unmanned control system, which will be later applied to larger vehicles. But it happened that it was decided to create a very small vehicle quite recently. And as Vadim Zubkevich said today, it will take off in January, that's the deadline. And control system will be worked out on the vehicle. The airships which were built earlier and which are being built now by colleagues from England, China, America, They all started designing a little earlier than the drone boom. And they did not include in their solutions the systems which are now being actively developed. It was decided to create a very small one to work out all the control systems on it now so that we could put this natural, ready-made system on the device so that it would not be damaged. So, we have this drone with the following characteristics. They're conditional. It's 500 kilos, 500 kilometers. This is what it will definitely perform. And it will be able to take and carry more and, for example, fly away at 1,000 and all that in the unmanned mode. This airship will be very modern. Automatic control systems will be worked out on it. It is not only following the route, which I have just explained, also leaving the airship shed in automatic mode, then automatic takeoff and landing, of course, automatic route following, and automatic mechanized, well, first of all, mooring, and secondly, loading and unloading. It is likely that 1 or 2 people may be needed, but not like before. A lot of personnel was required to take the airship out of the airship shed, to make it take off. Then many people were required to catch it, to moor it, load it, unload it, and so on. In the economic model of using this airship, well, this drone, and any airship in general, proportions change a bit, but in general, labor remuneration for pilots, technicians, ground crew, and so on, is almost a third of all the expenses. So, if this third is subtracted from the operating costs, then even small vehicles become economically feasible. The second thing is the creation of a serious large vehicle. Just like we jointly came to the conclusion that we're now making devices of this family, and then we will formulate the concept of the second vehicle, which should have a larger payload. Of course, it's quite likely that it will even have a rigid shell, where the body itself consists of a power frame, and then on top of it, it is either covered with fabric or lined with metal. That's all technology. Today it can be composite. So transition to the rigid scheme is quite possible on the second airship, but it's not obligatory. It can also be a semi-rigid scheme, but its payload will be something like 10 tons. So here is a 10-tonner. If it is 10 to 15 tons, it's a rigid scheme. If it is 10 or 8 tons, we can still use the semi-rigid one. But this vehicle will be of a completely different class. And it will be the most demanded in the logistics services market in the near future. Because the logistics services market for this load capacity has already been formed. And formed by helicopters, in particular, my 8 helicopters. So having created an economical airship of a given carrying capacity, as for the exact scheme, again, we will determine it a little bit later when the work with this vehicle will reach the stage of production. Now it's just a sketch project stage. So when we get to the stage of production, there will be time to do sketching of this vehicle. And this vehicle already does not fit into the standard airship sheds. And when we understand its specific carrying capacity, its tactical and technical characteristics, appearance, we'll understand its dimensions, and of course we'll understand what kind of airship shed we'll need to build for it. An airship shed is not a garage, right? It's still a kind of an assembly shop where you can set up serial production. You can place 2 airships here, assemble them as part of serial production, release them from here. On the side, we'll have small areas office space, production of certain parts, components and units, different workshops. So we're planning to build this airship shed. If in 6 months we start the development of this vehicle, and then in a year we'll understand what kind of airship shed we'll need, and start its construction, then within the framework of this project, we should, well, and we will have the time to build the airship shed and master the serial production of these 10-ton vehicles. Everything will be built taking into account a minimum of 1 unit per month to 2 units. That is from 12 to 24 units per year. This is what such an airship shed will be able to produce. This 10-ton vehicle is planned to cost somewhere in the region of my 8 helicopter. You can see how much my 8 costs. And in terms of technical characteristics, it will be twice as good. My 8 is 4 tons, and this one will carry from 8 tons. Well, 15, if it is 15, then the cost grows exponentially. So, if it has the same cost of production as my 8, just look at how much they sell for, how much you can sell this one for. We have calculated it ballpark, and with the production and sale of 12 to 24 vehicles, it turns out that the project can begin to pay for itself in 3 to 5 years. If this is the cost of the project, well, for the moment we're saying that it's possible to create all of it for $100 million attracted to the project. The project is at the pre-launch stage, something may change, but not much, that's for sure. And when we have serial production, these vehicles will be able to pay off the project twice in a year. And then the project can develop at its own expense, thanks to serial production, and there is space to develop, because the transportation system will not build itself, and 10-ton vehicles will not be enough. That is, the task is to create a design office, develop 2 vehicles, certify those vehicles, build an airship shed for their maintenance, assembly, and everything else. And production as well, right? We should have it. Well, we'll have an engineering center which will smoothly evolve into a design bureau. I think that by the time the airship shed will be built, a full-fledged design bureau will be formed. Next to the airship shed, of course, we'll have some areas for factory testing of those vehicles. That is a flight testing center. Then in that flight testing center, well, we'll organize educational institution for training, research certification of pilots and technicians somewhere around that airship shed. And we'll be able to build a few of those with that money, and a couple of those as well. Build an airship shed, master production, organize a training center.